Myself Munish Sethi, lecturer in mathematics in Government Polytechnic College for Women's Jalandhar. Today our topic is definite integral and problems. So definite integral and problems. So you know about integration, that is the indefinite integration. Now over today's topic is definite integral, that is we can find out the value of the integration, the definite value of the integration. The definition, we start from the definition. If phi x be any primitive or antiderivative of continuous function f(x) in closed interval a b such that ddx of phi x is equal to f(x), then the definite integral of f(x) from a to b equal to phi b minus phi a, that is the value of antiderivative at upper limit, that is at x equal to b. This is your upper limit and this is your lower limit, minus value of antiderivative at lower limit x equal to a. This is the definition of definite integral. Now the concept of definite integral can be understood with the help of some examples. You can say by using direct integration. Now let us take an example of a very simple function, that is 1 to 2 1 over 2x plus 3 dx. You have to integrate 1 over 2x plus 3 into dx. As you know, in the indefinite integral, the integration of 1 by x is log x. So it is log of 2x plus 3 divided by 2 from the limit 1 to 2, which mean we putting the value of upper limit in place of x. So you can get 2 into 2 plus 3 minus log of 2 into 1 plus 3. We put the upper limit and the lower limit. So we can get 1 by 2 log 7 minus log 5. So log a minus log b is equal to log a upon b. So this is your definite value. This is here. In the indefinite value we get the answer in terms of any function, but here we get the value definite, some definite value, that is the constant value. Now let us take another example. Let us take another example. Example 2, from 0 to 1 x e x dx. As you know about integration by parts, first of all we integrate with the help of by parts method, taking x as the first function and e power x as the second function. So first function as it is into integration of second, here we put the limit 0 to 1 minus whole integral 0 to 1, differentiation of x is 1 into integration of ex is ex dx. So this becomes x ex limit from 0 to 1 minus integration of ex is 0 to 1, ex is ex. This further by putting the upper limit first, we get 1 into e1 minus 0 into e the power 0 minus e power 1 minus e power 0. So after solving you can get e minus e plus 1 that is equal to 1. This is again a definite value that is equal to 1. Now we will take up another example 3. So very simple example, that is integral 1 to 2 dx x plus 1 x plus 2. So you can see that from the indefinite integral, this integration can be easily solved by using partial fraction. So when you separate it by partial fraction, you can get here x plus 1 and here x plus 2. You can put here this is 1 and this is minus 1. So separate the function by using partial fraction. Now using simple integration, the law of 1 over x integration is mod x plus 1 minus log of mod x plus 2 whole limit 1 to 2. Similarly, putting the value, the upper limit, you can get, if we put x equal to 2, you can get log 3 minus log 4, ठीक है, minus lower limit, if you put lower limit log 2, again minus log 3. So you can get log a minus log b, the log a upon b minus log 2 upon 3. Again we have log a minus log b, this is log a upon b, log 3 by 4 into 3 by 2, that is log 9 by 8 be the required value. This is again a definite value, that is the difference in indefinite and definite integral. The answer of indefinite integral is not unique. It depends upon the total method, or you can use the method. The answer can be vary, but in indefinite integral the answer is unique, that is a value. Now let us take another example, very simple example. After this example we will discuss the properties of some indefinite integrals. So another example, dx upon x square plus a square whole square, x square plus a square whole square dx upon 0 to a limit. So you can see that here we have x square plus a square a square. So here we apply substitution method. Here we put x equal to a tangent theta. This means dx is equal to a secant square theta d theta. When x is 0 implies 0 equal to a tan theta, which means theta equal to 0. Similarly, when x equal to a, this means a is equal to a tan theta. This means theta is equal to Okay, you can prove that theta is equal to, you can put a cancel tangent theta equal to 1 theta equal to pi by 4, pi by 4. So the given integral is equal to 0 to pi by 4, pi by 4. Dx is a secant square theta d theta. Now x is a tangent theta, a square tan square theta plus a square whole power square. You can see that 0 to pi by 4 secant square theta d theta. You can left with a cube. Now 1 plus, you can take a square common from the denominator, it becomes a 4. And cancellation, after cancellation you get a cube. So 1 plus tan square theta is secant square theta, that is secant power 4 theta. So this becomes 1 over a cube, 0 to pi by 4. Secant square cancel each other, 1 over secant square is cos square theta d theta, which mean you can change it by double angle formula, 1 plus a cos double 2 theta by 2 d theta. So this becomes 1 over 2a cube, the integration of 1 is theta, and the cos theta is sine 2 theta divided by 2, 0 to pi by 4. So after putting the upper limit and the lower limit, upper limit is pi by 4 plus 1 by 2, sine pi by sine 2 theta, sine pi by 2 is again 1. Next is minus 0, after putting lower limit, this again 0. So you can left with the answer 1 over 2a cube, pi by 4 plus 1 by 2. So this is again a definite value. So this is a traditional method in or the direct method to solve the definite integral. But sometimes the question is the integrand or the function inside the integral is not very simple, so that we can apply the direct method. So for those type of questions, or to remove the laborious process, we use some properties of indefinite integrals. So properties of indefinite integral, we use some properties, standard properties. So properties of indefinite definite integral, we use some properties of definite integrals. The standard property, the student, you have to revise on, remember it. The first property is by the change of variable, the value of definite integral never changes. That is, if we change the variable x to t, the value remains unchanged. This is the first property, a to b fx dx equal to a to b ft dt. By changing the variable x to t, the value remain unchanged. Similarly, the second property, the integral a to b fx dx, if we interchange the lower and the upper limit, the value of the definite integral is changed by negative sign. That is, the integral a to b fx dx is equal to minus of b to a fx dx. This is the second property. Third property, we can divide the integral a to b into two integral a to c fx dx plus c to b fx dx, where it should be remembered that the c lie between a and b. It is not out of the interval a b, open interval. It must be lie between a and b, the upper limit and the lower limit. So similarly, the fourth property, very important property, that is integral a to b fx dx, it is equal to integral a to b f of the sum of upper and the lower limit minus x dx, minus x dx. So the particular case is if we take a equal to 0 and b equal to a, we get integral 0 to a fx dx is equal to integral 0 to a f of a minus x dx. So this property, we take the, if we take a equal to 0, b equal to a, the property number 4 changes to this result. This is also the very important results using the property of, very important property of definite integral. Definite integral. So these are the 4 property. We left with 2 property, 2 more property. Later on we will discuss it. So these property, how these properties are applied in the questions. We can take the examples, using examples. Sorry. That is the, we take up the first example, minus 5 to 5 integral mod x minus 2 dx. So how you can solve it by the properties of definite integral? You see that here the mod we know that sorry, we know that mod x minus 2, these are of 2 type, it has 2 values. When x is greater than equal to 2, its value is x minus 2. When x is less than 2, its value is minus x minus 2. So we use the third property a to b. You can divide it into by a to c. Here 2 is clearly lie between minus 5 and 5. So we can divide or integral into 2 parts, separate the integral into 2 parts, minus 5 to 2 mod x minus 2 dx and 2 to 5 mod x minus 2 dx. You see that in the first integral, the x lie between minus 5 to 2, that is the x minus x is less than 2. So here mod x minus 2, it is equal to minus of x minus 2 dx. In the second integral, you see that the x lie between 2 and 5, that is x is greater than 2 but less than 5. So here the value of mod x minus 2, we use x minus 2 dx, it is 2 to 5. Now you can easily solve by simple integration. This becomes x minus 2 whole square divided by 2 integration minus 5 to 2, and similarly x minus 2 whole square but 2 to 5. You can putting the upper and the lower limit, you can get in the first integral, if we put x is 2, this becomes 0 minus, if you can put in place of x minus 5, you can get 49. Similarly, in the second integral, by putting the upper and the lower limit, you can get 9 minus 0. So on solving, you can get 29. This is again the definite value. So here we use the property number third. Similarly, you can take one more question like that, 0 to pi mod cos x. mod cos x. You see another. You see that the behavior of cos x in the first and the second integral, second quadrant is different. So mod of cos x, we know that mod of cos x, it is equal to when x in the first interval, that is 0 to pi by 2, in the first interval it is positive, so mod of cos x is cos x. When x lie in the second interval, you see in the first semester the trigonometry, the cos x is negative, so mod of cos x is minus cos x. So we using the property third, we divided by 2 integral into 2 integral 0 to pi, 0 to pi by 2 mod cos x dx plus pi by 2 to pi mod cos x dx. Here by using property number third again, we use property number third again. Because of this, in the first integral x is lie between 0 to pi by 2, so 0 to pi by 2 mod cos x is cos x, and in the second integral pi by 2 to pi mod cos x is minus cos x dx. So integral, you know that cos x is sin x, 0 to pi by 2, again 0 to pi by 2, again we have pi by 2 to pi. If you put in the first integral the upper and the lower limit, you can get 1 minus 0. In the second integral you can get sin pi 0 minus 1. So after solving you can get 2. So another definite value number, the answer is 2. So third property is very important to solve some typical problems like mod x minus 2 and mod of cos x. Now let us take the another example, that is integral 1 to 2, that is to solve integral 1 to 2 root x upon 3 minus x plus root x dx. You see that the function is typical. By the direct integration, it takes a lot of times. So we use properties of definite integral. Let us consider this is equal to I. Now you know that by property number 4, integral a to b fx dx, it is equal to integral a to b a plus b minus x dx. Here a is 1 and b is 2. So apply the property number 4, integral 1 to 2. This becomes 2 plus 1 minus x dx. Similarly, 3 minus 2 plus 1 minus x. Similarly, 2 plus 1 minus x. You can apply the property number 4. 2 plus 1. So after solving you can get 1 by 2. 3 minus x divided by root x divided by 3 minus x dx. This is number 1. Let us consider this in number 2. This is again I. Now you see that on adding 1 and 2, 1 plus 2 gives, put 1 plus 2, this become 2i, 1 to 2. You can see that the LCM is same, root x, root 3 minus x at root x plus 3 minus x dx. You can see the numerator and denominator cancel each other. We left with the 1 to 2 dx, which becomes x 1 to 2. This becomes 2 minus 1, that is 1. So 2i is equal to 1, therefore I must be equal to 1 by 2. So this is the required solution. So by using property 4, you see that the problem of definite integral can be easily solved. Now let us take another example of definite integral. Another example. Let us take an example of the trigonometric function 0 to pi by 2 sine 3 by 2x dx divided by sine 3 by 2x plus cos 3 by 2x dx. So by definite direct method of definite integration, it is not possible to solve this problem very easily. So we use the properties of definite integral. 3 by 2 power is 3 by 2. This power is a fraction. So you can apply the property number 4. It is equal to 0 to pi by 2 sine 3 by 2 pi by 2 minus x divided by sine 3 by 2 pi by 2 minus x plus cos 3 by 2 pi by 2 minus x. You see that this becomes another equal to 0 to pi by 2. This becomes cos sine pi by 2 minus theta is cos theta. Similarly, sine pi by 2 minus theta is cos theta, and cos pi by 2 minus theta is sine theta. So this is again this is again number 1, and this is number 2. Again, as in the previous example, adding 1 and 2 gives, so I plus I is 2i. So you're gonna get 0 to pi by 2 limit. The LCM is similar, same, sine 3 by 2x plus cos 3 by 2x. Similarly, sine 3 by 2x plus cos 3 by 2x dx. So on cancellation you can get we left with the dx. Numerator and denominator is similar, same, so we cancel each other. So on integration we get pi by 2. So 2i is pi by 2, therefore I is pi by 4. So hardly 2 to 3 minutes we can solve the difficult problem with the help of properties of definite integral. Here we again you can see that we use the property 4. That is, here A is 0 and B is pi by 2. So with the help of these 4 properties we can solve so many questions. Now we left with the 2 properties, that is the property number 5. Property number 5, that is this property is only for when the limits are minus a to a, that is minus pi by 2 to pi by 2 minus pi to pi, that is the lower and the upper limit are changed by only negative sign. So here we have 2 cases. Minus a to a fx dx integral is equal to twice 0 to a fx dx when f minus x, that is equal to fx. As you see in the chapter differentiation limits, this function is called even function and its value is 0 when f of a minus x is equal to minus fx. This is property number 5. Similarly,